Establishment Research Institute, which is just really a stone's throw from here. 20 years I've been driving by this school, I pulled in until today. Isn't that something? I'm really excited about it. First, a couple of orders of business I need to get out of the way before I forget. There's some important stuff, you know, and that's the gimmies. So we have these really cool party gifts. We hand these out at all our shows, okay? You know those string bags. If anybody wants one, want a couple of them, help yourself. They're right there. Okay, these, this really isn't a promo for Southwest Research. I just felt like I would bring something. These are really cool. They're little lights with like flashlights you put on your kid or your dog or your body. They are kind of cool. You can turn them off, which is really handy. All right, some of that. Also, I will be talking about the Mars Curiosity rover, which y'all probably heard of, landed, you know, on Mars a couple years ago, whatever. I have just a limited number of these cool paper cutouts of them, of it. This is like paper cutout on steroids. I've never seen one 27 pages long, so this is like for the really advanced paper cutout team. There's like, see something here. Also in my presentation, I give the link where y'all can go do this yourself and just print it out on cardstock. So I have a few of those. And then also we have some for our EMS program. I'm not going to talk a lot about it, but I will mention it. And these are more professional than Kelly printing out. While I'm here, I'm going to point out that I'm going to be talking about the radiation assessment detector on Mars later. And this is a 1-to-1 scale of it, okay? It's 3D printed, which I'm well aware of these days. And this is an engineering model of our windows on top. So anyway, before I steal all my own thunder, let me get this presentation. Okay, so my wife, I should also say, is a teacher, 20 plus years. She had a little hiatus in there while she raised our 3 children. And 2 of those are now at A&M, and 1 is headed anywhere but A&M, she says. It's right. That's what I keep telling her. You know, just because your brothers and your father went there. I feel like I'm immersed in the whole thing of education, right? I hear it every night. And y'all know that. And I'm very sympathetic, right? And so I understand. And I go out and I give talks to, you know, she's elementary, so I'll talk to her kids. I gave a talk one time, it was so cool. I did this kind of talk, you know, for children level. Afterwards, they all came up and they wanted an autograph, like I was an astronaut. So it was really cool to see them get excited and interested in something like this, because sometimes it's hard to connect the dots. I'm down here, maybe low socioeconomic, maybe who knows. And I'm from San Antonio, the Valley, where I grew up. You know, like thinking I'm never going to have anything to do with Mars, and voila, it's not true, all right. So I'm very, very passionate about it. And so I'm always trying to think of ways when I give these presentations, how do I spark the interest in math and science? You know, nowadays, people are really interested in get-rich-quick things, okay? I don't want to work, but I would like a lot of stuff bestowed upon me for the little tiny bit of work I'm able to do. And so that's a hard one to battle, it really is. You know, why choose STEM instead of going into business or something? And I'm not knocking any other field, okay? Every field is necessary, all right, I decided. But, you know, I just happen to be in the STEM-related field. Or why do you want to go to college, okay? Like I said, I've got 3 children, and those of y'all that have kids or have been around parents that have kids, you know it's a long road to hoe. To keep them on track and try to get them headed off where you think, you know, it's going to be a productive, contributing member of society. I think, honestly, there's a lack of understanding. What do scientists and engineers really do? Okay? And so we need to get out and educate everybody on what we do. So I'm really happy to be here now trying to help out with that. People think, you know, proof there was an iPhone. No, there was probably a team of 1,000 engineers behind that, frankly. And then a whole lot more in the production. You know, just in the design, 1,000 and then more for production. Math and science are hard. I want something that's easier. It's too hard. Frankly, I should say I've been struggling with that with my little girl this year. She got halfway through calculus and said, "Man, this is really hard. I want out." Okay, this is calculus. I mean, there's a lot of degrees really like calculus. Okay, so she's sticking it out, but it is hard. And people just not, like I said, not seeing themselves in that field. I don't know if this is an animated thing or why it's all the way to the left, but I pulled some stuff off the web that everybody can go look at. If you go to the Pew Center, okay, you can get this kind of information. This kind of shows you, you know, do a 4-year degree, private, okay, well, Yeah, all right. Well, private school looks like great on this data. I've got some other data that shows maybe that gap is a little smaller. But you can see in the high school diploma, you're around, 20-ish. This is a couple years ago. Bachelor's degree, you're up in the 40s. I will tell you, engineers, where I work, I don't know why I just started down this path. My wife's a teacher, I told you all that, right? Okay. I would be willing to give more property tax, by the way, myself, if my wife and all the other teachers could do, make a whole lot more. But in my place, an engineer might start in the mid-60s, okay? Which is not bad for really no experience coming straight out of school with a degree. So, I think I'm going the wrong way. Oh, it is animated. Sorry. I thought I did all the animations this morning. I went through and wiped them all out because they just discombobulate me. When I'm talking to kids, I'm talking about STEM, I'm talking about 4 years, I'm talking about 2 years. There's a lot of kids, and we all know this, that really don't need to go for 4 years. They're probably not really suited for it, but they can go off for a 1 year, they go for a 2 year. We've got some technicians and technologists at Southwest that work for us. They might have got a Hallmark or DeVry. Sometimes we might look down on those, but they're really not that bad. And they put out a trade. Okay, that's what they're doing. They're putting out kids with a background with a trade. And we've got plenty of technologists and technicians that are doing that and doing very well at Southwest. Well, so the stats here, y'all all know. I don't need to dwell on that. This was the other data that I pulled off. I pulled this off today, although I think it was referenced to be a couple of years old as well. But you can just see, the level of education and how you fare after you embark in the professional world. I think there's a lot of good reason to go off and try to get some kind of a degree, couple-year degree, 4-year degree, master's, doctorate, whatever. So this is a slide that I put up whenever I'm giving this presentation to a bunch of kids. Okay, do you like math and science? Do you like helping people, building things? Do you like to take things apart, solving problems? And then I throw the last one in for a little bit of humor. You wonder about aliens and your friends. And then I say, okay, this is what engineers do. A lot of people don't realize this. We design all kind of, modes of transportation: plane, train, automobile, ship, spacecraft, you name it. I once was offered a job with Zimmer Orthopedics. They're the largest orthopedic implant manufacturer in the world or nation. And they're up in Warsaw, Indiana. And I went into this facility. It was so cool. They had, the hips and the knees, you've seen these things, right, the artificial. And they had them in these aquariums of Ringer solution, which is that solution that kind of simulates bodily fluid, because you got to know if this thing's going to explode in a week or a year. And they're just sitting there doing this, and just beating them up. And I thought, well, this is cool stuff. This is really neat. So we do that kind of stuff. Okay, weapons, obviously, it's a necessary evil, I guess, is what I always say. But police, military, everybody needs help. Computer software, you all know it. So I always say, what do engineers not, do? And then I put this up for my math counts presentation. I'm just trying to show everybody that math and science are kind of a foundation for a lot of really cool things that we can all go out and do. Okay. And then, this is when I try to make sure people realize what my upbringing is and why, if I can do it, there's hope for others. I was born in Edinburgh. We moved up to New Braunfels in middle school. Saw them fighting unicorn. What is Holmes? Well, don't be offended. You know how sometimes that security question is, what was your high school mascot? No, Park. I keep wondering what them scared Germans, and I'm half German, but we're thinking unicorn. Anyway, so I'm a unicorn. Went off to A&M and got my BS in mechanical engineering. And then I went off to Stanford, and that's an interesting story. I was working at NASA Langley Research Center when I got out of school in Hampton, Virginia. And I was there for 5.5 years. They have a program, those that have children that are thinking about this kind of field. One cool thing about the government, it's kind of like Southwest. You don't get rich quick by any stretch. We're all nonprofits, but they have a neat program where they will send you back for a graduate degree. and they will pay for the tuition, and you pick the school. So I picked Stanford. And they pay your salary while you're gone. Whew. Yeah. So I was like, bring it. And it just turns out that my wife is from the San Jose area, so I was able to live with her family. So that was a lot of the reason to go there. Besides the fact that Stanford is a good school, but when you're in graduate school in engineering, you're not going to be seeing your wife or your husband independent. Right? So it was good to have her with her mother, and I was off doing that. The other thing, and that's why I really made this huge, that I think is huge, and we've got to tell the children, the students, co-op engineering. I did that when I was at Texas A&M. Okay, interning, same kind of thing. I got to go off to General Dynamics in Fort Worth, where they make the F-16 Falcons. And if I'm dating myself, they don't make those there anymore. They're doing the advanced type fighter. I think they're doing parts of the F-35 there now. But at the time, they were building F-16 Falcons, which were the Thunderbirds, if you remember. And they're still flying the Thunderbirds, aren't you? You've seen the Thunderbirds. It is a fantastic program, you know, and that was in '85 that I went off to do that. I was making $20,000 a year back then, so you figure doubling every 20 years, so that's, you know, that's like $50,000 or $40,000 to $50,000. Okay. It was really nice money. My son has done it, and he did it down here at Toyota. So he got to live with us. He went to Toyota, and he was making $22 an hour, I think, or something like that. So the co-op program is a fantastic program. Plus, as a hiring manager at Southwest Research, when I see resumes that come across the desk that say, well, I've got, you know, da cum laude, and this laude, and this laude, and I work as an intern or a co-op, so I already know kind of what engineers are doing. That makes a big difference in who I consider to bring in for an interview. Not who I hire necessarily, but who I interview. So I push it big, all right? After the NASA Langley thing, I decided to come back home to Texas, and I came in Southwest Research, had a position in their Space Science and Engineering division. So I came back to do pretty much what I was doing at NASA Langley, but here, which was very cool. Southwest, as most of y'all might already know, is really a little oasis of technology in San Antonio. San Antonio is just not a hotbed of technology. We're a hotbed of a lot of stuff, but not necessarily technology. You know, we're working on that. We are. We now have our Toyota, and we've got some good wafer stuff going on, and that's been around for a while, ebbs and flows. But anyway, it's a neat little oasis of technology, and there's, well, I'm going to talk about some more about Southwest here in a minute. And I would like to say I've got normal hobbies, right? So I try to relate to the kids and say, look, I'm just kind of a regular guy. Southwest, for those that haven't been there, it's 1,200 acres. It feels a lot like a NASA site that, you know, I used to work at or have visited. It's just a big campus. It's like a college campus. And it was founded back in '47. I think we've had some of our folks speak at these things, so bear with me if you've already heard this. The guy that started it, his name is Tom Slick. Many of y'all know about the Slick Park that's over here on 151. That's him. Cable Ranch was this ranch up here, right? A lot of the property out here was part of the Cable Ranch, and he donated that to this nonprofit venture. He actually started 5, I believe, different nonprofits. There's a wonderful biography out of him that talks about his life. He was a very eccentric person. And he decided that we needed some technology here in Texas, that we were losing it to the east and the west coast, and that it made sense for him to start it up on his ranch. There was nothing out here, by the way, on this side of town back then. But we are pushing 3,000 employees at the Institute. Our sister organization, which is now renamed the Texas Biomedical Foundation, y'all know me, it's right there on Route 410 with the primate colony. I think it's the largest research primate colony in the nation. I got an interesting story to tell you about that. Anyway, he started that one, so those two are still going. And of course, our other sister outfit, the Mind Science Foundation, down in downtown San Antonio area. I don't know if y'all have ever been over there, but he believed in the paranormal. In fact, he passed away evidently on a trip hunting for the Yeti. Airplane down, he died in that airplane wreck. So anyway, he started the Mind Science Foundation. It's still a going concern there in San Antonio. And they bring in really cool mind guest speakers and talk about some really cool mind stuff. So I've not been over there, but I've seen their announcements, and it looks pretty interesting to me. anyway, those three are still going. We're the largest of them. And we've now spread all over the nation. You can see that here. And we go to little areas where they need more of our capabilities. For instance, we'll go up to Warner Robins, Georgia, to the air base there. We go up to Tinker. We have about 100 folks from our division that are in Boulder, Colorado. And those are the guys that you see on, I think I'm going to talk about that in a minute. You see those guys on Discovery Channel, PBS. They're the planetary scientists that are talking about and researching how all of us happened. Okay, bear with me on that too. Everybody's got opinions, but still, there are cosmic forces at work here in some form or fashion, and they're studying that kind of stuff. So it's really cool. So this is just a couple photos of our buildings over there. We've got a lot of PhDs, okay? We've got a lot of master's folks, a lot of bachelor's folks. And we've actually also just taken on a Durham, New Hampshire office at the UNH campus. We took over a little activity of some earth and ocean research activity there, and that's now part of the Southwest Research Institute. And we do give tours. We have a lot of programs. You'll probably already know that. We have a lot of programs. We have the YES program. Oh, I needed to put a slide in here on that. The Young Engineers and Scientists program. Please write that down. Yes. Why yes? I don't have it in my presentation. My son did it, and it's fantastic. It's a 3-week program, and you live, you come every day like you're going to work to Southwest, and they take you through all our divisions, and you do these really cool activities. My son was writing JavaScript for a Science Operations Center or something that we have there. But the Young Engineers and Scientists program, we still do that. And then we have a lot of externships, so any of your past students maybe that are, or actually even I think some of the high school seniors partake of some of our E12 program, but that may only be through a couple of high schools. But the externships, students that have gone off to Aggie Land or to, they do it with the T-SIPs, sorry for the Longhorns in the crowd. Even the Longhorns should come down, and we'll take them on tours for a day, okay? And they're called externships. And you can talk to our it's our, I believe it's our training office. I can get you more information on that if you're interested. But it's really a neat program that we have. And okay, so we've got Space Science Department, Space Systems Directorate, where I come from, and then the Planetary Science Directorate, that's the one up in Boulder. So these are all just kind of neat little things they're doing. You can see here, hopefully a resemblance to that cut in half full-scale model of one of our instruments. We actually blew up, we have a high altitude airship program, and we blew that up in the Alamo Dome. We rented the Alamo Dome. And they blew this thing up in there, and it's really cool. We got some cool photos of that back at home. This, let's see. This looks like IBEX, Interstellar Boundary Explorer. That was another really neat program that we headed up. We're the principal investigator institution on a lot of programs, and the cool thing about that one, to me anyway, was, well, one, it was trying to get as far away from the Earth as it could while staying in orbit about here. So it was like a 5-day orbit. It was almost to the moon. Okay, that's how far out it went. Most low Earth orbit, 90 minutes, you're around, and you're back, all right? And it's fairly low. But this thing here, they needed to get away from all of our atmospheric turbulence, okay? It would cloud its vision. And so it got way out there and then used some plasma instruments, a couple of plasma instruments looking at ions and electrons and neutrals, basically looking at the boundary of our solar system as our solar system flies through the galaxy. Now that was a big concept that I had to understand when we first took on the program. Like, what? The whole of the solar system is flying through, and we've got this big wave off the front of us, just like a boat going through water. And so that's what this IBEX was all about. Interstellar Boundary, that's our boundary, explorer, trying to look, they thought there might be a battle shock, okay? They were looking at that. I think it turns out that there may not be, which is another neat thing about a lot of these science programs. You know, there's a lot of theories out there. We don't know that. A lot of scientists pontificating about stuff. And then they'll go out there and prove them right or wrong. And it's cool either way. You know, and so that's what this one did. It's proven some things correct, and it's also found that in some areas our models were incorrect. So that was that one. I don't know if y'all remember this here. Just not too long ago, that little Philae lander that came off of Rosetta, and it landed in the shadow, and it couldn't recharge its arrays. Poor thing. Well, have these two instruments on there. Okay, this is an ion-electron spectrometer. Okay, and I call these, we do a lot of these plasma instruments over there in my division. I call them cosmic flypaper, because here's what's happening. You got ions, you got electrons. They're flying around, right? They've been flying around for like a billion years. Flying in a straight path, right? Or every now and then maybe getting bent by some gravitational thing, big gravitational thing. But then this little guy, which is about that big, sticks his neck out and it gets sucked in, and its whole travels are over. And so by measuring the energy and the mass of that, scientists can refine their models. Okay, and that's what this guy was doing. And this was a UV spectrograph that was also on the same thing. So it's looking at UV light. Now, neither of those were on that Philae lander. They were just on the orbiter. So we built those here. Deep Impact, 2005. NASA sent up a spacecraft that split into two pieces, and one piece impacted Comet Tempel 1. And the idea was, you blow this hole in this comet with what they called the impactor. And then the flyby spacecraft, which was way back behind, and they split way back here, and this guy sped up, and this guy kind of laid back. Boom, you blew it, and then this guy came by and took cool pictures. And hopefully, you were going to see the strata in the divot that you made, right? So then, the geological types could look at that and decide the history of this comet. It was a really cool idea. We built all of the guidance avionics for that. That was a 40,000 mile per hour impact. So the comet was flying at 20,000, we were flying at 20,000, and you had to hit, you had to connect. So that was an impressive feat, and it happened on July the 4th. Okay? So I'm trying to wake up the family, you know, at 2 in the morning. Come on, let's go see it. You know what I got? My wife got it. Leslie got it. Interestingly, when the flyby came by, right, after the impactor had done its job, the flyby comes by to do its job, and what does it see? A cloud of dust. Unfortunately. So they're trying to repurpose the flyby for other photographic things out there. The other neat thing was, you know, those who've seen the Armageddon movies and other movies where I don't know, we try to make sure that we have the technology to hit these things before they hit us. This is just a photo of some of the avionics we've built. This is always neat, you know, when you think about computers for spacecraft, and especially as a taxpayer, these things are like, you know, $1 million, $2 million each, okay? And it's a computer, it's just a computer. But fortunately for me, I know what goes into those, and, you know, they're a bargain at $1 million. To be honest, it's amazing what we have to do to prove to the customer, who's NASA, that yes, this thing will work, and it will work reliably, and it won't need any service over its entire life, because we can't service that stuff up there for the most part. Hubble, we all know about servicing missions to Hubble. Some things can be serviced. This could not. This was a deep space mission. You couldn't get out there to do anything to it. So, it's kind of cool when you compare it to the computers and laptops and things that we have today. In fact, those have a lot more computing power for, you know, $600 or whatever you're paying down Best Buy than this thing does. But they would not make the survive the launch and all that. Okay, the one that I really like to talk about, certainly it's starting to get dated, but I'm trying to ride this horse as long as I can, is the Mars Science Laboratory, Curiosity rover. We built the radiation assessment detector for that thing. I got another slide on that here in a minute. If you remember, just before Curiosity rover was Spirit and Opportunity, the two little guys, right, that had the solar array flip outs that drove around, and they went for way past their expected lifetime. This was an interesting story. The solar arrays got covered up with dust on one of them, and I don't know which one, and it quit working. And then all of a sudden it came back to life, and its camera panned around and saw a trail in the dust of a dirt devil that had just come through and went right over it and cleared off its arrays. So they have wind and things like that on Mars. It's very light density air, it's not, or gas, I should say, but it's anyway, it cleared them off. But the Curiosity was an order of magnitude, if you will, bigger. Okay, those were, I forget how, those were, you know, like this. Curiosity was like a Mini Cooper. And so, and there's some really cool animations. if you haven't visited the NASA EPO sites, to go out and grab these animations and show them to the kids. The kids just lap this stuff up. There's some really cool animations of both spirit and opportunity bouncing. I always tell the kids, it's like the Super Bowl when we were kids. Those balls that just seem to bounce 50 stories tall. That's what they did. Y'all seen that probably, where they blew this balloon up around spirit opportunity and it landed, just bang, bang, and then after it got done bouncing, the balloon deflated, the pedals opened up, and the rover drove out. It was crazy. So, because this one was so big, and I've got an animation, I think, of that deployed and landed, it had to do a different manner of landing. And when you watch it, you think, there is no way they made that happen. And it did. Oh, well, so why do we want a radiation assessment detector, radiation detector on Mars? Well, you need to know what the environment is if you're going to send people there, obviously, because if you send them in a little bunny suit, or if you send them in a big spacesuit, could be problems with the radiation environment. And this is for folks that are interested in more of the geeky side of it, but this is really cool. This is that section there, right? And these are the electronics that are working this sensor. Here's the sensor up here. These are scintillating materials. So an energetic particle will hit these things and they fluoresce. And all you have to do, right, it's real easy. All you have to do is put a photodiode on there that can see the wavelength of the fluorescence, and then it'll know, okay, you just got hit by something. And so if you engineer, well, I'm bragging, it's not really engineering. If you science that right, and then the engineers get in and package it right for you, but if you science and engineer it right, all of a sudden you can start picking out all these different energies of particles, okay, of X-rays that are that are hitting your instrument where it is. The other cool thing about RAD, it was, if not the only one of the only instruments that was on during the entire trip to Mars, because you got to send your astronauts there too, and so you need to know what's it like on the way to Mars. And so it was collecting data the whole way. And that was one of the neat findings we found out about. Okay, so this is, and I've got another photo showing this window. Here's why I'm really proud of the window. It's the only thing you can see, okay, that we made. The rest of it's underneath it. So I bring the window. So there's the window. This is the engineering window, okay? This window, I tell you, I just take your camera, I'm sorry. This window is 2.5 mils thick, so almost a human hair, okay? And the reason is that the instrument here is looking up from the bowels of Curiosity rover. It's protected down in there thermally and otherly. Radiationally too, that's another story. Radiation detector needs to be protected from radiation. But anyway, it's actually looking up through the window. Okay? And the scientists did not want the attenuation of the signal that's coming, this is looking up at things that are coming down. If you've got a thick aluminum plate in your way, you're attenuating the radiation before it gets to your detector. You don't want that. Okay? You want to be able to see unadulterated radiation. And so that's why the thin window. Okay, so why am I harping on the window? Because, whenever we do these jobs, we think, oh, we've thought of everything. Well, we know we haven't, but we hope that we have. What we didn't think about, and when the first pictures came back after the landing, we're seeing this picture here. These little black spots, that's rock hail. That's hail that was raining down on the rover. And you'll see in the sequence why. These retro rockets were stirring up the surface of the planet as it sat there and hovered. And the rocks just, and then it came right down on top. And one of the instruments, as I understand it, actually was damaged. I'm sitting here ready to brag about the only part of my little work. That was mine. That was my window that's on the rover. Imagine if it had a hole in it. You didn't tell me. So we designed it for the pressure. They tell you what the pressure is going to be, and we make sure we analyze. We go finite element work on it. We need to do finite element. By the way, this is funny. My little girl, Dad, why do we need calculus? Well, like for engineers, we use finite element analysis. Okay, for those that haven't done it before, it looks like you've just built a virtual Lego model. It's a lot of little squares. Well, then there's just gobs of behind-the-scenes calculus taking place to analyze all those Lego blocks, if you will, and decide what are the stresses that are inside of the structure under given loads that you tell it. Okay? And so there's gobs of calculus. I don't do the calculus, thank the Lord, but somebody's doing the calculus behind the scenes, and we're getting, I don't know if I showed that, I did, this. You can't see the Lego outlines because I turned them off, but this is a stress plot. This says, how many PSI of stress are you getting in this thing when it's blasting off or landing or whatever. So there is a lot of calculus that goes on every day in scientists and engineers' lives. Interestingly, this thing had to weigh less than 4 pounds, and it had to be less than 5 watts. That's a night light. That's a night light. Night lights are 4 watts. So that's all the power that JPL, NASA JPL gave us for our mission. You got 4 watts, buddy. So you have to do, and that kind of hopefully points you to why are these things so expensive. I mean, I could have slapped a Dell computer with some really simple interface cards up there and done the job, but it would have, an Intel chip, the current processors, they're burning about 100 watts in a single processor chip. If you open up your computer and you look inside there, that's why they have that big humongous fan and the fins and all the special cooling on them now. It's a lot of heat. Well, we have 4 watts. And then, like I said, it has to operate. And as I recall, it was for 5 years. I mean, the mission, I think, is a 2-year mission, but they wanted it to be good for 5 years. And then you have to worry about planetary protection. We can't send our Earth germs to Mars. That's a problem. Tom Cruise had a movie, Orson Welles movie, right, where they died from our cold. They call it cold, they call it Earth cold. We don't want to send an Earth cold to Mars. So your instrument has to be baked out, cleaned, and otherwise put through the ringer so that it doesn't send any stuff that way. That instrument was around $16 million. A third of that, because these things are so expensive, a third of that came from Europe because the cost of these missions is getting so high that we're now sharing across the water with ESA, European Space Agency, and NASA. So we'll sometimes provide them an instrument, they'll provide us one, and so on and so forth. So we did a lot of work with them on this particular mission. Oh, that's just another clearer picture. Probably should delete one of these. So, pass the potatoes. So, this picture, one of these pictures, there was one like this anyway. Selfies, the rover's taking all these selfies. That's what we have in these pictures. And that's like a selfie stick. And one of these pictures showed up in the Geographic. And my grandmother, who's now 90, I think she's 93 or 4, all right? She sends us this every year for Christmas. That's what I get. So I opened up Grandma's Geographic and I saw my window. And I was like, oh my Lord. I should have passed over and died right there. And so, come Thanksgiving that year, I took that to the table right in Schulenburg. My sister lives up in Schulenburg. And I said, hey, y'all, guess what? Yeah. You know what I got? Past it. I love my family, right? There's no big headedness. My dad always said, don't get the big head. That was fun. This was a cool picture of the scintillating stuff that we're using inside of there. It's transparent, and the particle hits it and it glows. These things are being used a lot, by the way, in airport X-ray machines. So this kind of same technology is being used in there. And I think, honestly, a lot of this, I don't know about this one specific, but a lot of this is, the space business figures this stuff out. It's really expensive, but they had to figure it out. And then once they figured it out, all of a sudden, now the airports have it. And they're using it, and it's a lot cheaper, and it's a neat technology transfer thing. I'm not even going to go over this. This just kind of, every one of these blocks is gobs and gobs of manpower. Okay, all the different tests. So we have to do thermal tests, vibration tests, EMI, EMC tests. We basically have to put these things completely through the ringer to make sure that they're going to make it once you launch them. Now, there's some real people over at the Vibe facility doing the Vibe test on that very instrument that's on Mars right now. So San Antonio, this is so cool, San Antonio has hardware on Mars. So I'm very proud of that. That's very cool. And here we are in our thermal vacuum facility. So we have a big chamber. We've now got a new one over there that basically simulates the cold of space and the vacuum of space. So you have to take your instrument through that. And the number 3, there's a couple others, you can download this in the presentation. The number 3 science discovery, the first year that MSL was around, was by the radiation assessment detector, and it found that, you know, there's potential harmful radiation out there that we're going to have to plan on for our trip over to Mars. And it's caused by primarily these solar energetic particles. The sun, you know, gives us life, but the sun also gives us death if we let it. And our atmosphere is, you know, really, we don't know that. It's the only reason that we get to sit here and talk and exist, because it protects us from a lot of what the sun is spewing out. Okay, so this was a cool site. I just put it in here for completeness. There's some really neat educational EPO stuff on all of the NASA sites. Oh, okay, so I have a full video, and I'm telling you, these things are great to show the kids.
How do you get to Mars? If you want to send a spacecraft all the way to Mars, first you'll need a fast rocket to escape the pull of Earth's gravity. The heavier your spacecraft, the more powerful your rocket needs to be to lift off. Next, make sure you launch at the right time. Mars and Earth orbit the Sun at different speeds and distances. Sometimes they're really far apart, and other times they come closer together. About every 2 years, the two planets are in perfect positions to get to Mars with the least amount of rocket fuel. That's important. The total trip is over 300 million miles. Finally, make sure your aim is right. You can't shoot for where Mars is and launch it. Aim for where it will be when you get there. It's a lot like how a quarterback passes a football. Also, you may need a few thrusts to correct your direction along the way so you don't miss Mars. If all goes well, you'll get to the red planet in about 7 or 8 months. Then, if you actually want to land on Mars, well, that's a whole other challenge.
My wife and family and I went out to this launch, and I have to say, because I've worked on this program for 3 years, I started crying when the thing went up. It was really moving when you see what's happening.
That great things take many people working together to make them happen is one of the fantastic things of human existence.
Not only we've driven the rover, we've moved.
So one of the things I tell the kids, by the way, when you see all those people working around the rover, all those people don't have degrees. A lot of those people are tradespeople, you know, they're technicians. And they're well-trained technicians, but you don't have to have a college degree to be really in a cool spot.
We've moved its arm, put it all through its paces, but it's been in a thermal vacuum chamber, kept very cold. And parts of it have been in a centrifuge. We've done drop tests, pull tests, drive tests, load tests, stress tests. Just an amazing amount of testing this vehicle has gone through. We've tried every way of operating in the vehicle using the software, literally thousands and thousands of hours of software testing. It's been just an amazing...
Okay, so I have to tell you something else. I told you earlier about the Spirit opportunity that had their flip-out arrays. Well, this thing was so big, it needed so much power once it got there, that flip-out arrays wouldn't work, okay? They couldn't practically make that work. So it has a nuclear power plant on it, right back there, okay? Sticking kind of up at an angle. And it's called an RTG, a radioisotope thermonuclear generator. And it's basically, you know, like a little slug of plutonium or, you know, one of those radioactive things. It keeps heating a circuit that makes electricity for them. They actually pump the cooling fluid all through the vehicle to help keep the vehicle warm because it's very cold there. And so, by the way, New Horizons, the one that just went by Pluto and gave us all those cool pictures of Pluto, that was on the Southwest Research Program too. It also had one of these. So they're very dangerous. I say that. They're very safe because they've been designed, but people are very afraid of them. So
It's several years really of constant testing and development, finding problems, fixing those problems, and going on to the next problem. I think she's ready to go.
C, this is the LD on channel 1. LC, you have permission to launch.
Roger. Proceeding with count.
Minus 10, 9, 8. 1.
going to go and she's going to be successful, absolutely. It's going to go and she'll be good.
There go the solid rocket booster.
You should have parachute deploy around 1.7.
This thing deploys
Parachute deploy.
supersonic
Start
parachute.
accelerating.
It's using the parachute faster than such a sound.
Digital has separated.
There goes
Ground
the
is down.
shield.
Standing by for backshot separation. We are in higher flight. We're at altitude of 1 kilometer descending. Standing by for sky crane. Sky crane started.
So the sky crane is the one that brought the rock hail down upon us. It also did its job of lowering it back to the surface. Now it's amazing to see that all that stuff had to work.
What a fantastic demonstration of what our nation and our agency can do. I could only think of the words of Teddy Roosevelt as I was sitting there. It is far better to dare mighty things even though we might fail, than to stay in the twilight that knows neither victory nor defeat. And the team brought us victory today.
Today, right now, the wheels of curiosity have begun to blaze the trail for human footprints on Mars. This is an amazing achievement.
Well, today on Mars, history was made on Earth. The successful landing of Curiosity marks what is really an unprecedented technological tour de force. It will stand as an American point of pride far into the future.
We've got a long mission ahead of us, and because of that and the capabilities of this rover, we have possibilities for just monumental science accomplishments.
Within 2 months, the team found an ancient riverbed, evidence of flowing water.
We have found a habitable environment that is so benign and supportive of life that probably if this water was around and you had been on the planet, you would have been able to drink it.
So always motivational to see that. I'm close to the end. That one. Oh, this is always cool. The kids love this. Let me see if I can do that side. Of course, shoot that five underneath there. My bad. I always tell them that mechanical engineers build weapons and civil engineers build targets. So what's really cool about this from an engineering perspective is this projectile has to get through this, bunker without exploding and wait until it gets near the asset that it's trying to take out to explode. So it's really cool. I have to be careful with these war monitor videos, but the kids love it. Oh, and then let's try it now. See if I can confirm my mistake. So I throw this map up and I take a look. I started down at Edinburgh, went to New Braunfels, and then A&M, then Langley. Spent a little bit of time out there in California, and then went back, and so try to let them know that anybody can do this. All right, not just for little me. All right, any questions?